Suppose that I'm writing a program where I have to ask the user 5 times for a number, and then I have to put those numbers in a list, and then I also have to figure out that that list does not contain any duplicates. So if you were to write that piece of code, I'd say you would sort of put it in a loop, right? So you're going to say, okay, for I in the range of 5, so run this program 5 times, I am going to ask the user for an input, and I'm going to modify it to be an integer value, and I'm going to say give number, and they'll give me something, and then I will define a list outside the for loop, and I'm going to say x is equals to a new list here, which is empty, and then x dot append j here. So whatever the value of j is going to be, it's going to be added to the list, and this process is going to happen 5 times. Then after that, I will then have to convert it into a set because I need to remove the duplicates from that list, and then I will revert that back to a list again. And if you don't know what these functions are doing, they're basically saying that these are constructor functions. So we know that a set only contains unique values. So if the user had given us, let's say, the number 5 times when I asked them the input, it's going to give me a set of just the value 1 just once, or the value 5 just once. And so you can revert that and put it back into your list again. So again, in this case, this entire thing, what it's doing is that it's asking the user for 5 numbers, and then it is going to basically only keep unique inputs, right? So as an example, if the user gave me a list of 5 numbers and my x became 1, 1, 2, 2, 3, I only want the duplicates, only want the unique values, so the set function will give me a set which will look like 1, 2, 3 here, and then the list version of them will just make it 1, 2, 3. Pretty cool. All the previous videos basically talk about how you would go about doing this. Here's a problem though. What if I want to do this process 10 different times, but then not consecutively inside a loop? So don't think you can say, oh, you know, I'm put a loop outside the whole thing. So for let's say m in range of 0 to 10, right? Run this whole thing 10 times. That's not what I'm saying. What I'm saying is I'm going to ask the user for this stuff. I'm going to use this piece of code, and then I'm going to have some arbitrary lines of code, and then maybe I'll ask the user for 5 numbers again, so this block is repeated. Okay, so in that case, I can't really put the entire program in these arbitrary lines of code inside this for loop. So there needs to be some sort of modularity where I'm able to repeat some pieces of code without explicitly writing them down. So you might think, hey, you know, for loops and while loops do that. Well, the for and while are mostly used to repeat a particular piece of code X amount of times. So for a while loop, you will run code until a condition is met, right? And then for a for loop, you'll run a piece of code X amount of times. So basically how long the range is, how long your collection is, how many times you want to run, X times. But none of these don't really tell if I want to run this code once over here at line 52, and then once at line 85, and then once at line 206 maybe. In that case, you won't be able to use them with a for loop or a while loop. So if statements, while loop, for loop, they're mostly for a control step of your program. So think of your branching of the code maybe, but not really solve this idea of modularity, what I need to do if I want to run a piece of code again and again and again, arbitrary times, but not really explicitly inside a loop itself. So if you're looking to reuse your code like this X amount of times or wherever you want to, that's when functions really come in. So I'm going to write in big bold words, functions. This is my favorite topic in Python. So we have played around with a lot of functions. Append is a method that is type of a function. Int is a function, so I'm going to underline all the functions right now here. Set and list are constructor functions. Input is a very cool function. We know that range is a function. So we have played around with several functions so far, but we haven't actually been able to make our own function. And so that's what we're going to be learning today. We're going to learn how to make our own functions. So if I ever wanted to ask the user for 5 numbers and only keep the unique inputs, I won't have to write this long piece of code every single time I needed to do it. Instead, what I'll say is that this whole piece of code, I'm going to define it only once, and I'm going to give it a name, and let's say I call it function X, right? Function X. And so if I ever want to ask the user for 5 numbers and only keep the unique inputs, I'm just going to call in my line of code, if this is the lines of code, I'm just going to call this guy, and Python will know that I'm calling upon these lines of code, and it's going to go back and execute them for us. And that's basically how these functions are running. When you come at this line in your execution and you say x.append some value j, Python will go back to the definition of where this method is defined and how to use this x list and this j integer and, basically add them into your list. So we'll be talking about how to make our own functions here. Let's start by making a very small list of all the functions we sort of know of, and I'm going to call them, they're going to come under the heading of regulars, the methods we have, and constructors. So constructors basically will take a variable and convert it into the type of constructor you specify. So int is going to take a variable and then it's going to convert it into an integer. You also have string, you also have a list constructor, and so on and so forth. Methods are more or less going to be applied on a single object of a particular type. So if it is a string, then I'll be able to use the upper method to convert a string into uppercase. If it's a list, I can use the extend method to then take a collection and pass it here and have all the elements of that collection added to the list that you want to extend to. It could be a set, and I could call the intersection method and pass in a set here, and then whatever the intersection of this set and those set were, you'll get that out as a result. The regular functions are the ones that more or less apply on everything. We know that there's a print function, there's an input. We have talked about the type function, which will basically return the data type or the data structure of a variable. More specifically, we also know about the min-max ones. So there's a min, there's a max, the sum function, and they're basically applied on integer collections. So not strings, but lists if they've got integers in them, and even tuples if they've got integers in them. So all of these methods, all of these functions, so I'm going to put a heading of functions, all of these functions are basically performing one particular task. So these are things to note. So a function performs one specific task. So you don't want to make them very generic. You don't want to have them do every single thing. You'll notice that you have an upper method to do uppercase, lower method to do lowercase, title to do title case, capitalize for capitalization. And so every method and function sort of performs one specific task here. We will also note that functions can take inputs. It can be one or more. And they can have outputs, right? But there is also the case that they also might not have inputs or outputs. And that is totally fine. So let's see an example. The print function, if I were to say I have a variable x equals 4, y equals 3, and let's also have a list here, z equals 1, 2, 3 here. Me writing the code print x, y, z is currently taking 3 inputs, so a function can technically take one or more inputs. But then we also know that there is the let's say there is the z.pop method, which is technically a function, and we'll notice that it doesn't take any inputs at all, so functions might not have inputs. Similarly, z.pop will return a value, so I'll be able to do I equals z.pop, and what's that going to be? 3 is going to get returned out, and that's going to become the value of I. So in that case, this method has an output, but we also know that the print function, let's say print of x, if I were to store it in a variable and print the value of that variable, it will show up as none, which means that this function doesn't really have an output. So you're going to have all kinds of functions in Python, predefined and the ones that you're going to create on your own too. So it really depends on the problem you're trying to solve, but all in all, functions are going to be helpful in writing better code, readable code, and easier to write code too. And we'll see how that comes into play when we look at examples, maybe, going forward. I also want to look at functions from a mathematical perspective. So we know there are math functions, a function that will take an input and give you an output. So if I take an example here, and I say f of x is equals to x squared. So this is a math function. And we know that, let's call this z here. So z is equals to x squared. We know that if x is 1, you're going to apply 1 here, square it, and that's going to be the value of z, which is also 1. And then if x is 2, then z becomes 2 squared, which is 4, right? That's a very easy sort of function where I might add that it is taking a single input. So this math function takes one input, and z is being returned out, right? The value of z, and so it has one output. Okay, let's look at another example. I could have f of x, y, where I'm plugging in x minus y, right? So in this case, let's say this whole thing is z again. And so I could say if x is 1 and y is 1, then 1 minus 1 is going to be 0. And then if x is 2 and y is 1, again, z is going to be 1. So in this case, you now have 2 inputs. So this function, this math function, takes 2 inputs. And that's fairly okay, and you'll still get 1 output here. So very similarly, you'll have functions like this in Python. So if I were to use this idea of, hey, there's an input going in, there's an output coming out, I'm gonna sort of remodel that as like a box maybe. And so let's say instead that we have a box here, right? And you're going to write some code. So it is your job to write the code for your function that you want to define. And I'm going to give it a function name. So I'm going to say this is some function x here. And the way you want to think about this is that there are arrows going in, coming out, and these are going to be your input, and this is going to be your output. Now, unlike a math function where the output is always going to be there, I am going to right away tell you that the inputs are all optional. So you can have 0 inputs, you can have 1 input, and you can have multiple inputs. So either one is okay. For the output part, you can have 0 outputs, you can have 1 output, and there is technically a way to have more than 1 outputs too. You can just return like a tuple of multiple results. So in this case, you have a choice basically on how many inputs you want, how many outputs you want. But what's more important is what this piece of code is doing. And I mentioned earlier that your functions need to do one specific task, and sort of this is where the magic needs to happen. This is where you need to write the code to do that particular task. It might be related to this input you provide, and it might be formatting the output you give back, but it's very, very important that you sort of have an understanding of there needs to be a code in here that is doing a particular task. So the way you write the code for a function to define a function, it's kind of very similar to how you have if statements and for loops. You're going to indent some piece of code, have some keywords, and that's going to basically distinguish what you're doing for your function. So let's start really, really easy. I'm just going to write, I'm just going to draw the basic sketch of a function, and whatever I do in red is, think of it as things that are sort of necessary or are part of the code. So you're going to write DEF for define, and I'm going to add parentheses, I'm going to have a colon, and let's say we indent some code and we write some arbitrary pieces of code, right? Okay. And I will also have a return here. So again, all of these in red are keywords, actual keywords in Python that you need to have sort of. We'll talk about return in a minute, but the def value, these parentheses, they need to be there to define a function. And so now what I write in blue is basically you fill in. So here, after I do def, I'm going to then specify a name for my function. So right now I could just call it function x, right? And then here I could have a piece of code. So statement 1, let's do statement 2, right? So this code, this function has 3 lines of code. Statement 1, statement 2, and then this return. And then you're going to have a value to return. Okay. This whole piece is called a function suite of code. So basically this is going to be the code that executes whenever you call upon that function, whenever you invoke it. So def basically means define. I'm going to add that too. And finally, within these parentheses, you can pass arguments or parameters. It doesn't really matter. So right now I'm passing 2, but please remember that the inputs in Python, you can have 0, you can have 1, you can have more. Right now I'm opting to have 2 parameters in there. And so if you have multiple parameters, they're always going to be comma separated. And I'm going to use this lingo a lot, but arguments, parameters, or inputs. they're all the same thing. Similarly, return value and output are the same thing. So if we were thinking about inputs and outputs, just for this diagram, well, for functions, you might want to think, okay, this is a function that takes two parameters. So these are two parameters here. And you'll basically put a name of a variable, any variable that you want in there, to be the names of those parameters. Right now I'm saying they are called P1 and P2. And so these are the two parameters for your function. They're always going to be comma separated. And again, you can have one parameter, you can have two, you can have 0, you can have multiple. If it's 0, you're just not going to have P1 or P2 here. You're just going to have this empty. Okay, now this thing, this is the last thing we need to worry about, is only going to come in when you want to have an output. Like I mentioned, you can have 0 outputs. In that case, you just won't have a return value or a return keyword in there at all. This will just be your function. It does some tasks, so some code is still chugging, but you're not returning anything. But if you do, you're going to have this keyword, and you're going to follow it by what you want to return. What you want, let's do this, what you want your output to be. There could be another variable that you compute within these two statements, or you can have more statements. Again, this keeps going too. It doesn't matter. Your return could be up here. It could be the very first line inside your suite of code. What's going to happen is once a return is hit, your function stops working. Your function basically says, okay, I'm going to exit out. So your program's still going to run, but any line of code after a return, if your return is hit, those lines are going to get skipped. So usually when we think of these is they're usually at the very end if it's linear code. But if we have conditionals going on, if we have an if statement, then we can have returns in the middle there. But we'll look into more detail when we look at some examples here. So based on the definition skeleton here for a function, let's define a function that prints the sum of the numbers 1 and 2. Okay, so the way you'll do it is you'll say def, I'm going to call it adder, so you can call it anything basically, but the name should be sort of descriptive of what that function is doing. And we're going to say that it's not taking any inputs, no parameters here, right? And then I'll indent my code, and then I'm going to print 1 plus 2 here. Pretty cool, right? And so once this has been defined, I can then, below it, after it's defined, I can then use this function right away. So what I can do is I can say adder. I can call this function. This is me. So if this is me defining a function, so this is the definition of a function. This is me invoking a function, so invocation of a function. So you only need to define a function once in your code, and you can then use it multiple times. So I could have adder, then let's say I do print dash dash, and let's say I do adder again. So what's going to happen in your output here, let's say this is your terminal, right? What's going to happen is that when Python comes at this line, so I'm going to write lines 1, 2, 3, maybe 4, 5, and 6. Python will come to lines 1 and 2, and it will realize that there is a function adder defined in your namespace. And let's not worry about namespace here for now, but let's just assume that in memory, there is a place where this function is being stored. So Python currently knows that there is an adder function, and that's it. So at line 4, when that function is invoked, when it's called, so I can also say invoked or called. I'm calling a function. When this function is called, then Python will go back up to wherever it was defined and then go through and execute those lines that you want to. So whatever the function wants you to do. So in this case, when at line 4 you see adder being called, you're going to go back to the definition and you're going to print the code, the suite of code that accompanies this function, and it just says print 3. So you're going to get 3 out. At line 5, so after that, once the print statement happens, you're currently at the very end of your the definition of your function. There are no more lines in the suite of code, so Python will then jump back to where you were. So I executed line 1. I found that there was a function definition for adder. Okay, at line 2, this was associated with this adder. Line 3 does nothing. At line 4, I will jump back. I will execute this code now. So here at line 1, I was only acknowledging, Python was acknowledging that there exists a function called adder, but now that I call it, I'm going to now execute it actually, which means I'm going to run these lines, and it will print 3, and then I will go back the way I came from. So I will travel back here to line 4, and then I'm going to move to line 5. When I move to line 5, I'm going to print 2 dashes. Then I'm going to move to line 6, which means that I will go back to the very top where the function is defined, execute these lines of code, print 3, and then go back the way I came from. And now I can move on to line 7 and further. So that's basically how a function definition and invocation is going to be happening for all of your functions going forward. You'll notice that this function doesn't do much. Every time I'm going to call it, it's always going to print the number 3. That's not really that fascinating. So maybe I have to make a better function. Maybe instead of the adder function always printing 1 plus 2, maybe I wanted to return the value 1 plus 2. And if you remember, if I don't have a return, then it's not going to return anything. So there are no outputs. So if I had done x equals adder, it would have then, and if I had then also done print the value of x, it would have in terminal. So let's put that again in terminal. It would have at this line, it would have printed 3 because that's me saying go back and execute the function. Well, in the next line, I'm saying store the return value, whatever is returned from adder, store it in x and then print it. Well, you'll notice that there is no return statement here. This is a return statement where I do return the keyword and then some value or a variable to return. If there isn't anything, then this function is not really returning anything. So it will actually print none. And to test this theory out, I recommend that you do something like this. How about you go to your terminals or to your Atom and do this. Y equals print 12. What's going to happen is that in your terminal, you'll have 12 printed. And then if you were to run this code, so you'll have 12 printed, but then print of y will give you none. Because if you were to go back to how print is actually defined by the developers in Python, it has no return value. So if this was the box for the print function, there is some code, and we'll make those arrows. In this case, for print function, you will have multiple inputs. We know that, comma separated, right? But 0 outputs. If there are 0 outputs, you can't really store the value that is returned from a function that actually isn't returning anything. So this function, our function adder, isn't really that good. It is, whenever I call it, it only prints the number 3. I'm not even able to store the value of 3. So to rectify that, how about we try to return the value of 3, 1 plus 2. In that case, let me erase this too. In that case, what we'll do is we'll define adder 2 here. So no input so far, but instead of printing, I'm going to return the value of 1 plus 2 here. Okay, and then let's call adder 2 below. Similarly, when this line of code is executed, Python will acknowledge that there exists a function called adder2, all right, but I'm not going to execute it. Here, I'm actually calling it, right? So calling adder2. And once that happens, in your terminal, you won't have anything printed because you didn't actually print anything. You didn't use the print function, but I could do y equals adder2 and then print the value of y. So when this line of code is executed, you will go back and Python will go back, jump back to this line, and it's going to say, okay, I'm going to now execute this function, and it's going to run these lines of code, the lines in the suite of code for that function. And it's basically a single line that says, return back the value of 1 plus 2. Okay, well, Python will say, okay, 1 plus 2 is 3. So what you want me to do is return back this value of 3. Cool. You're going to travel back in that direction, just like before, but now you're going to take this value with you. That 3 is going to be with you the whole time. And then if you see, if you notice this, so adder2 function is going to then evaluate to the number 3 because that's what's being returned here. So y then becomes the value 3. So the variable y has the value 3, and if you print it now, you're going to get 3 printed. So if I had a, let's do this. If I had a test function, if I had a function test and it doesn't take any inputs, but what it does, it prints ABC, and then it returns, let's say it returns the number 6. Okay, and let's try to call this function by itself first. And what we'll do is we'll make the terminal again, and we're sort of gonna see the example of what happens here. So these are lines 1, 2, 3, and 4. At line 1, Python will acknowledge that there exists a function test. All great. And then what it does, it prints the value of ABC, and then it returns the value of 6. Cool. At line 4, when this function is called, you're going to go travel back, and you're going to now execute these lines. So what's going to happen is at line 2, you're saying print the value of ABC. So you're going to get ABC printed over here. Then it says return the value of 6. Awesome. You're going to travel back, and you're going to keep the value of 6 with you. So what that means is that this whole thing, this function, becomes the value 6. Now, we're not storing it in a variable, so nothing's going to happen to it. But let's say now I have another line of code. Now I do y is equals to test, and then print y times 2. Okay, let's do this one in red. And so these are lines 5 and 6. So when line 5 is executed, you're going to do the same thing. You're going to go back to the definition of the function and execute the lines in the suite of code, which means you have to print ABC. So you're going to print ABC first, and then it says return the value of X. Okay, so you're going to travel back, keep the value of 6 with you because that's what you're returning, and then this whole function will become 6 because that's what's being returned. And now this will just looks like, this line will just look like y equals 6. And so if I'm printing y times 2, we're going to get 12 printed over here. I can even do one step less here. I can even make it a little simpler. I can even go a little simpler here and just do print, and this might be a bit bizarre for you, but I can even do print test times 2. Now, if you're able to understand this one, then that's it. That's the end of the video too, and you should be able to fairly easily figure out how functions can be defined without even writing any code in Atom. So now what's going to happen is that at line 5, I'm saying print this thing times this thing. Okay, we're going to evaluate this test function first. These are parentheses. So whenever the function is called, you're going to go back and execute the lines of code, which means that you're going to print ABC as a string, and then you're going to return 6, the variable 6. Okay, so you're going to travel back, you're going to keep the 6 with you, and so your function will become the value 6. And then you're going to print 6 times 2, which is going to become 12. So I'm gonna leave off this video here. In another video, we're gonna look at how to actually write the code in Atom, but we've really written a lot of code here too. But this is just, again, a first sort of a lecture on what functions are, how they're defined, and then in class we're gonna look at more examples of how to do it in Atom.